Astronomy Month. Let's go look at the sky. Ah. No, I've been April Fool's by the weather. Okay, so today being the first day of April means it is the first day of Global Astronomy Month. And in light of everyone being stuck inside at the moment in quarantine and self-isolation and so on and so forth, I'm going to post a fun fact about space and astronomy every single day this month for Global Astronomy Month. Let's start with neutron stars. So neutron stars are extremely dense dead stars. It is the remnant core of giant massive stars, and I mean massive. Only stars with a mass of 10 to 29 times the mass of the sun turn into neutron stars at the end of their lives. Your typical neutron star has about the mass of 1.5 to 3 times the mass of the sun, but are squished into the size that's only tens of kilometers across. So it's easy to see that these stars are dense. How dense, you ask? Your typical neutron star is around 400 trillion times more dense than the sun. So a teaspoon heap of neutron star matter would weigh about the same as Mount Everest. Do you know what time it is? It's time for Global Astronomy Month Fun Facts Day 2. Today's fun fact comes from the comfort of my pantry. Have you ever wondered what neutron stars and pasta have in common? No? Really? You never thought about it? Well, aren't you in for a wild ride? Neutron stars, like the name suggests, are made of mostly neutrons, but there are some protons and other nucleons in there too, held together in nuclei, which are the centers of atoms. And the shapes of these nuclei, deep and deep down into the neutron star, have a bit of a pasta-y equivalence. Nuclei at the crust of the neutron star are shaped like gnocchi. As you go further down, the pressure and density increases so much that the nuclei are stringed down into long pieces of spaghetti. And then they get squished small, they go into flat sheets of lasagna. From there it gets even more intense. Neutrons whiz out of the nuclei and create anti-spaghetti. And then anti-gnocchi is created, and then there are no more pasta equivalents to describe the shapes of nucleons further down in neutron stars. But there, Space Facts for Global Astronomy Month, Day 3. So we've talked about neutron stars a lot over the last few days, but let's talk about the closest neutron star to the Earth. Its official designation is RxJ 185-635-3754. Catchy, isn't it? It's about 400 light years away from the Earth within the constellation of Corona Australis, that is the Southern Crown, and it's believed to have fallen from the brilliant death of its companion star 1 million years ago. It has a mass of about 10% less than the Sun, and it's as small as 40 kilometers wide. And while it may be a small, dense star, it's also a hot star, sitting at 434,000 degrees Celsius on its surface. It's part of a group called the Magnificent Seven, which is a group of neutron stars between 400 and 1600 light years away. Come back tomorrow to find out how we can navigate with neutron stars. Welcome to Global Astronomy Month Fun Facts Day 4. Today's fact is navigating through space with neutron stars. Many neutron stars are highly magnetized and rotate quite rapidly. These are known as pulsars. They're kind of like cosmic lighthouses that send us an intense beam of light at very precise intervals. Fastest spinning known pulsar is PSR J1748. It spins at 716 Hz, that's 716 times per second. Pulsars can be used to accurately determine the position of objects moving in space at thousands of kilometers per hour. It works similarly to GPS, but instead of using satellites, we use the precise locations of these pulsars and their precise frequencies to work out locations in space. Early tests of this navigation system were able to locate the International Space Station traveling at 28,000 kilometers per hour within 5 kilometers. That's about the equivalent of locating someone walking within 10 meters, which is about as good as GPS is at the moment. How cool is that? We can navigate in space. Global Astronomy Month Fun Facts Day 5. And yes, I'm wearing the same shirt as yesterday. It's the weekend. Do not judge me. Let's talk about comets. A comet is often described as a cosmic snowball because they're mostly made out of frozen gases and dust and rock, and they're usually only a few kilometers across. But when they get close to the sun, that is when the magic happens. As a comet gets close to the sun, the frozen gases melt, producing an atmosphere called the coma, and the coma can extend for hundreds of thousands of kilometers. High-speed particles from the sun, known as the solar wind, push the coma into a long, bright tail, and that is what makes the comet look so beautiful. But comets have not one, but 2 tails, the dust tail and the ion or gas tail. The ion tail always points directly away from the sun, and the dust tail is leftover dust within the orbit of the comet. Come back tomorrow to find out where comets come from. Global Astronomy Month Fun Facts, Day 6. Yesterday we talked about what comets are, but where do they come from? Since comets are made up of frozen gas, dust, and rocks, they must come from somewhere very cold. In fact, most comets come from beyond the orbit of Pluto in the Kuiper Belt or the Oort cloud. Just for reference, the Kuiper Belt is about 20 to 50 times further away from the Sun than the Earth is, and the Oort cloud is about 2,000 to 200,000 times farther away. Being this far away from the Sun, you can imagine it's quite frigid out there. There are two types of comets that are more or less based on where they come from. There are short period comets that whip around the Sun over very short periods. One example is Halley's Comet that goes by the Sun every 75 years. The second type is, you guessed it, long period comets. These are comets that have an orbital period of about 200 to 1,000 years. Come back tomorrow to find out about a comet that might be visible in our skies soon. Global Astronomy Month Fun Facts Day 7. I have exciting news to share with you. Potentially, maybe, bear with me. There might be a bright comet tracking across our night skies in the coming months. A new comet was discovered on the 28th of December last year using ATLAS, that is the Asteroid Terrestrial Impact Last Alert System. Official nickname is C/2019Y4, catchy, I know, but it is nicknamed the Atlas Comet. It is currently crossing the orbit of Mars, making its way ever so closer to the Sun. It will be closest to the Earth on the 23rd of May at a distance of 117 million kilometers, about 303 tons of distance from us to the Moon. It will then continue its journey towards the Sun, making its closest approach on the 31st of May at a distance of 38 million kilometers. That's closer than Mercury. Its tail might be bright enough to be seen with the naked eye, and it might even be brighter than Venus eventually. Comets can be very unpredictable though, so we might just have to wait and see. Although, new observations of Atlas show that it's already possibly breaking up, so we might not be able to see it. No. Global Astronomy Month Fun Facts Day 8. In light of tonight's pink supermoon, let's answer the question, what is a supermoon? The term supermoon is attributed to an astrologer called Richard Knoll, who coined the term in 1976 as a new or full moon that coincides at or near within 90% of perigee, which is the moon's closest approach to the Earth in its orbit. The closest distance between the Moon and the Earth at perigee is 356,400 kilometers. The Moon's distance from the Earth tonight is 356,907 kilometers. That's only 507 kilometers off its closest approach. The technical or sciencey term for this phenomenon is called perigeicity, which in normal words means close and in a line. That is, the Sun, Earth, and the Moon are all aligned. Almost. If they're perfectly aligned during a full moon, then we have a lunar eclipse. If they're perfectly aligned during a new moon, then we have a solar eclipse. Right now, they're just more or less aligned. Global Astronomy Month Fun Facts, Day 9? Comets. Most of them come from regions in space within the gravitational reach of the Sun, but there's one that's a little bit special. It goes by the name 2I/Borisov. Why? Well, the 2I tells us that it is the second interstellar object that we've observed inside our solar system, and Borisov is the name of the person who discovered it. It was discovered by Borisov on the 30th of August 2019 at his personal observatory with a 0.65 meter telescope that he built himself. It wasn't confirmed as an interstellar visitor at first. When Borisov first discovered the comet, he calculated its near-Earth rating, which turned out to be 100%, i.e. dangerous! This is the comet, by the way, which is totally safe. Don't worry, it's all good now. On the 8th of December, Borisov, the comet, reached perihelion, which is the closest approach to the Sun, and it is now on an outward trajectory outward from the solar system. Goodbye, Borisov! Global Astronomy Month Fun Facts Day 10. Hold on to your hat and socks, space lovers, because on this day, exactly 1 year ago, space nerds around the world saw something never seen before, an image of a black hole. Or more precisely, the silhouette of a black hole. I remember staying up until some ungodly hour waiting for this huge announcement to be made, and my goodness was I absolutely blown away by the incredible scientific achievement that this is. So let me show you how this image was actually taken. The astronomical data from this one image came from the Event Horizon Telescope, which is a collaboration of 8 different observatories around the world. There are a few from America, a few from Europe, and even one from Antarctica. Now, when these 8 observatories combine forces to look at the one object, they are essentially making a telescope that is the size of the Earth. So basically, it took a telescope the size of the Earth to take this photo. That's pretty amazing. Global Astronomy Month Fun Facts Day 11. Houston, we have a problem. On this day 50 years ago, Apollo 13 launched from the Earth and made its way towards the moon. The crew were going to land near a crater called Fra Mauro, I think that's how you say it, but that plan was swiftly changed when they heard a large bang 56 hours into the mission. They briefly lost communications with Houston and started seeing some sort of liquid being ejected from the spacecraft. 26 seconds after the accident, Command Module pilot Jack Swigert reported, "Okay Houston, we've had a problem here," which was then echoed by the commander Jim Lovell with the immortal words, "Houston, we've had a problem." Turns out that one of the oxygen tanks in the service module had exploded. In other words, they've got a big problem. At this point, the mission turned into a mission of survival, and fantastically they did survive. They splashed down in the South Pacific on the 17th of April 1970 in a generally good condition after a 143-hour mission. Wow. Global Astronomy Month Fun Facts Day 12. A few days ago I talked about the first ever image of a black hole and how that photo was taken, but let's talk about the model of that picture for a moment. This black hole is a supermassive black hole at the center of a massive elliptical galaxy called M87, so naturally the black hole is called M87 star, where the star designates that it is indeed a black hole. But how massive is supermassive? Well, this black hole is 6.5 billion times more massive than the Sun. But because this is a black hole, which is an incredibly dense object, it's only about the size of the solar system. I know, only. But imagine this, 6.5 billion suns squished inside the solar system. Yeah. On top of that, matter is accreted onto this black hole so quickly that it consumes the equivalent of 90 Earths per day! Thankfully for us, it's about 55 million light years away, so we're good. Global Astronomy Month Fun Facts Day 13. Since we're all buzzing about supermassive black holes, let's have a chat about our very own supermassive black hole at the center of the Milky Way galaxy. The supermassive black hole at the center of our galaxy goes by the name Sagittarius A star, but don't let the name deceive you. It is not a star, it is a black hole. I really need more sleep. It's not quite as supermassive as M87 star. In fact, it's only 4 million times more massive than the Sun. With a mass like that, its Schwarzschild radius, which is essentially the point of no return, would be about 80 times the distance from us to the Sun. We are about 26,000 light years away from Sagittarius A star. Now you might think that this isn't very far at all, but don't worry, there's no reason to fear. We are happily orbiting around the center of the Milky Way galaxy at a speed of 230 kilometers per second, so we're good. I don't know if you can hear the karaoke going on, but this happens all the time and they suck! Global Astronomy Month Fun Facts Day 14. We are made of star stuff. Have you ever wondered what this actually means? Or have you wondered where each and every element in your body actually comes from in the universe? Well, today we're going to find out. The human body is made up of mostly 6 elements, that is oxygen, carbon, hydrogen, nitrogen, and calcium and phosphorus, with a few other trace elements like magnesium and sulfur and whatnot. But how and where were these elements formed in the universe? Take a look at this cosmic periodic table. It shows us where in the universe each element originates from, whether it be hydrogen and helium and lithium for the Big Bang fusion, or heavier elements forged from dying stars. The oxygen in our bodies was formed from the explosions of massive stars, along with some of the calcium and phosphorus and nitrogen. Carbon and nitrogen were formed from the deaths of low-mass stars like our Sun, and some of the calcium in our bodies were formed from the explosions of white dwarf stars. This really goes to show that we are indeed made of star stuff. Also, personal fun fact, I have a tattoo that says Per Astra Constructum, which means built by the stars. Global Astronomy Month Fun Facts Day 15. Wait a second. That means we're halfway through. Astronomers are dumb. Okay, stick with me on this one. I'm going to show you how astronomers have gotten something backwards. Quite spectacularly. The magnitude system is used as a measure of brightness. So bright objects will have a magnitude and faint objects will have another magnitude. Now you would expect brighter objects to have a larger magnitude, but in fact it's actually the opposite. Brighter objects have a smaller magnitude and even sometimes have a negative magnitude. Let me give you an example. The brightest star in the Southern Cross has a magnitude of 0.76. However, the brightest star in the night sky, called Sirius, has a magnitude of minus 1.46. Now that's seriously bright. The main idea behind this magnitude system is kind of cute. So the first group of stars to come out at night are called first magnitude stars, then the second group are the second, and then that goes on until the sixth group of stars. Mathematically, one star that is 1 magnitude brighter than another star is 2.5 times brighter than the other star. I hope that makes sense. Global Astronomy Month Fun Facts Day 16. Galaxies! We live in one. The Milky Way galaxy is a spiral galaxy, but what other galaxy shapes are there? There are two main categories for shapes of galaxies. They are the spiral galaxies, like our Milky Way, and the elliptical galaxies. There are also subcategories between them too. This is the Hubble tuning fork. It's a classification system invented by Eddie Hubble, the jazz American trombonist. I'm just kidding. Of course it was developed by Edwin Hubble. Elliptical galaxies are kind of like footballs in space. Like this one. Then you have a peculiar galaxy somewhere in between ellipticals and spirals called the lenticular galaxy. It has a big bright bulge, kind of like an elliptical, but also a flat disk of gas, kind of like a spiral. Then we have our spiral galaxies. You have your regular spirals, which are your all-round galaxies. Get it? Because they're round. Then you have your barred spiral galaxies, which have a distinct central bar across the middle of the galaxy. And aren't they just all so beautiful? Global Astronomy Month Fun Facts, Day 17. Did you know that Saturn has a hexagon-shaped cloud? Saturn has this really interesting hexagonal-shaped cloud on its north pole, and it's very persistent, and it's been perplexing astronomers for years. It was discovered during the Voyager missions in 1981, and then revisited by the Cassini spacecraft in 2006. There are a few hypotheses that attempt to explain the shape of this hexagonal cloud. Early ones said that it was a standing wave of clouds and of wind, driven by a larger storm south of this hexagonal cloud. But when Cassini arrived, it observed no such storm. One explanation, which has been tested in the laboratory, are wind gradients, which is the rate of change of the speed of the wind. Drastic changes in speed can induce very unstable behavior in fluids just like Saturn's atmosphere. The team that tested this set up a cylindrical rotatable tank that was able to rotate fluids inside it at different speeds, and under certain conditions, they produced this, a very stable hexagonal shape. Global Astronomy Month Fun Facts, Day 18. Let's talk about white dwarf stars, the remnant cores of dead sun-like stars. Most dwarf stars eventually fade away, although the universe hasn't existed long enough for us to actually observe that. Alas, some special white dwarf stars explode in a... Wow, rude. As I was saying, some white dwarfs explode into a huge cosmic firework called a Type 1a supernova. These special white dwarfs exist around a companion star, and while these two best friends orbit around each other, the white dwarf actually leeches matter off of the other star until it gets to about 1.44 times the mass of the Sun. Once a white dwarf reaches this mass limit, called the Chandrasekhar limit, it goes boom, quite spectacularly. Since this special type of supernova is triggered by stars of the same mass, they all explode with the same brightness, which means we can use them as standard candles throughout the universe. And it was this characteristic that enabled astronomers to measure the accelerating expansion of the universe. Global Astronomy Month Fun Facts, Day 19. A star has been yeeted out of the Milky Way galaxy. Yes, you heard me correctly, a star has gone yeet! A star has been discovered by the Southern Stellar Stream Spectroscopic Survey, or S5, collaboration. The star is a hypervelocity star, which basically means it's going really fast relative to all the other stars in the Milky Way galaxy. This star is called S5-HVS1. It is an A-type star, which means it is bright, hot, and white. Sounds like my boyfriend. This star is flying out of the Milky Way galaxy at a whopping speed of 1,017 kilometers per second. Now I'm sure you're wondering how the star actually got yeeted, or yote, in the first place. The S5 team took the orbital characteristics of this particular star and integrated backwards in time to look at where this star possibly could have come from, and found that it came from the center of the Milky Way galaxy. Which means S5-HVS1 was yeeted by the supermassive black hole at the center of the Milky Way galaxy. Global Astronomy Month Fun Facts, Day 20. Did you know that most of the members of the Black family in the Harry Potter series are actually named after stars and constellations in the night sky? Probably one of the most notable examples is Sirius Black, who is named after the star Sirius, which is also known as the dog star, and coincidentally, probably not a coincidence at all actually, Sirius Black turns into a dog. There's also Bellatrix, which is the name of the third brightest star in the constellation of Orion, which coincidentally is also the name of Sirius Black's father and Bellatrix's uncle. Cygnus, Andromeda, and Cassiopeia are all named after constellations. Then you also have Regulus, Alphard, and Arcturus, which are all named after stars. I give the naming of the Black family 1 million stars for creativity. Global Astronomy Month Fun Facts, Day 21. I have some new space news for you, hot off the press. LIGO, the Gravitational Wave Observatory, has observed the dramatic collision of 2 black holes. Now this isn't particularly new or exciting news. LIGO has been observing the wobbles of space-time for about 5 years now. However, this is exciting news because the two black holes that collided have very different masses, and this has never been observed before. The merge, dubbed GW190412, involved two black holes, one with a mass 8 times the Sun and one with a mass 30 times the Sun. This mass ratio is roughly equivalent to the stuffing in a regular Oreo to that of a mega stuffed Oreo. Thank you, gravitational wave astronomer Christopher Berry, for that delicious analogy. Now, this observation also verified one of Einstein's predictions about general relativity, of course, once again. The prediction that it verified is that gravitational waves chirp, like go whoop, at more than one frequency. That was fun. That was a fun noise to make. In fact, the data supports the hypothesis 1000 to 1. That's amazing. Global Astronomy Month Fun Facts, Day 22. Have you ever seen a light in the sky and weren't really sure what it was? I'm going to give you a few tips to figure out how to turn those UFOs into IFOs. That's an identified flying object, by the way. First question we need to ask is it really big and are your retinas burning? If your answer is yes, don't be like this guy and stop looking at the sun. If it looks like a star but it's moving relative to the other stars, it might be a satellite, and if you look out for some astronauts waving at you, then it might be the International Space Station, like this. If it whizzed by so fast that you almost missed it, then that is likely a meteor. If it was particularly bright, then it's a fireball. Fireball. And if it ended in a dramatic explosion, then it's a bolide. And last but not least, if it looks like a satellite and is moving across the sky but is blinking, that's what I like to call Jetstar. For those watching this who aren't Australian, Jetstar is an Australian airline, so if it's blinking, it's a plane. Global Astronomy Month Fun Facts, Day 23. Today's topic can be a bit heavy. It's gravity! I don't know what that laugh was, but all I know is that I need better space jokes. Anyway, one of the biggest misconceptions about space is that there is no gravity in space. And this is far from the truth. Gravity actually exists everywhere in space. Gravity is what allows the Earth to orbit around the Sun and what allows the Sun to orbit through the galaxy. Without gravity, we'd actually be flying aimlessly through space in a random direction. The gravitational force between two objects, whether it be between you and me or between the Earth and the Moon, depends on the mass of the two objects and the distance between them. Formally, the gravitational force is the universal gravitational constant multiplied by the two masses divided by the distance between those two masses squared. So as the distance between two objects increases, the gravitational force decreases but never gets to zero. Have I lost anyone yet? So as long as matter exists, the influence of gravity exists everywhere. Global Astronomy Month Fun Facts, Day 24. Today's space fact is dedicated to the Hubble Space Telescope because it's Hubble's 30th birthday! And for 30 years, despite a little hiccup at first, Hubble has gone on to take some magnificent photos of space, contribute to scientific discoveries, and inspire tens of thousands of people across the world, including me. The first time I knew that I wanted to be an astrophysicist was in high school after watching the Hubble documentary narrated by Leonardo DiCaprio. I remember sitting there with the one-size-fits-none 3D glasses slipping off my face and looking up in awe of these magnificent photos that this phenomenal telescope took. So in homage to this great fantastic telescope, for the next 30 days, starting from today, I'm going to post a fun fact about Hubble, talk about some of the fantastic photos it's taken and some of the great discoveries it has contributed to over the last 30 years. So, here's to you, Hubble. And don't worry, I will also be doing my Global Astronomy Month Fun Facts on top of this as well, so you get more videos! Yay! Global Astronomy Month Fun Facts, Day 25. Let's talk about different types of stars and how we categorize them, but in a bit more of a fun way. Now, the formal way to categorize stars is on a Hertzsprung-Russell diagram, which categorizes stars based on their luminosity, or their brightness, and their temperature, also referred to as their color. Now, I've made a little change to this Hertzsprung-Russell diagram to have a bit more of a fun vibe to it. Relatively young stars fall along this diagonal line called the main sequence, or as I call them, the basic bitches. And we have the Sun down here, which is the close boy. Further down the shininess scale and temperature scale, we have the red dwarf stars, or as I like to call them, the cool kids. Older stars tend to be giant stars that have moved off the main sequence, or as I like to call them, the big boys. Then you have supergiants, which are the real big boys. Some stars are very hot and massive, so they are the hot and thick stars. Then, my personal favourite, the white dwarf stars in their own little world down here, or as I like to call them, the dense boys. Global Astronomy Month Fun Facts, Day 26. Today's question is, how are stars born? I don't know. You'll have to ask my parents. I'm just kidding. Kind of. Anyway, stars are made up of mostly hydrogen and helium gas. In fact, most stars are 99% hydrogen and helium. All of that hydrogen and helium gas come from big molecular clouds like this one, the Orion Nebula, which is my favourite. These gas clouds are not completely uniform and smooth, like a glass of water. They are lumpy and clumpy, like a glass of Milo. Each of these clumps contain more mass than the less clumpy gas around it, so it has more gravity to pull in more of the gas. Slowly, these clumps attract more and more gas particles, building up like a snowball rolling down a hill. Eventually, there is enough mass that the gravitational force increases the pressure so much that it ignites nuclear fusion. And then bippity-boppity-boo, you have a star. Global Astronomy Month Fun Facts Day 27. How big can a star get? So our sun is pretty big. So big in fact that it can fit 1.5 million Earths inside of it. However, it is actually technically classified as a yellow dwarf star. So if the sun is a yellow dwarf star, how big are some of the bigger stars in the universe? Might want to sit down for this one. There are giant stars like the star Arcturus, which is a red giant, which is about the same mass as the sun, but has swelled up to be 25 times wider. Not impressed yet? Well, wait until you hear about the supergiants. Betelgeuse is probably one of the most well-known supergiant stars in the night sky, and it is about 1,000 times bigger than the sun, which means it can fit about 870 million suns inside. Still not impressed? Well, here come the hypergiants. There is a star called VY Canis Majoris that is 1,500 times wider than the sun, and it can fit 9.3 billion suns inside of it. Global Astronomy Month Fun Facts Day 28. Prepare yourselves, the Milky Way galaxy is going to collide with the Andromeda galaxy. Oh no! Wait, stop. What are you doing? What does it look like I'm doing? I'm panic buying because I didn't ask for any details about how this would actually affect me. It's okay, don't worry. Andromeda is more than 2.5 million light years away. Huh. And even though it's traveling a whopping 110 kilometers per second, the collision won't happen for another 4.5 billion years. Oh, okay. I guess there's nothing to worry about then. The only thing we need to worry about now is a massive asteroid that's flying near Earth tomorrow. What? Global Astronomy Month Fun Facts Day 29. It's almost over. I bet you wouldn't have guessed this! Asteroids are protecting themselves from the coronavirus. Kind of. An asteroid called 1998 OR2 is currently flying by the Earth at a very safe social distance of 6.3 million kilometers, and it even looks like it's wearing a face mask. Look at it. It's wearing a face mask. This radar image was captured by the Arecibo telescope on the 18th of April. The team who captured the image, who have been wearing face masks to prevent the spread of COVID-19, must feel like they've been looking into a cosmic mirror. Look at it. I have first class in physics, and I just tried to zoom in on the video, thinking that it would zoom in on the background. Global Astronomy Month Fun Facts Day 30. The last one. Here we go. Pigeon poop helped astronomers discover the afterglow of the Big Bang. Seriously! Back in the mid-1900s, there were two possible theories that attempted to explain the origin of the universe. The first being the steady-state theory, and the other being the more well-known Big Bang theory. And in 1946, two astronomers using this super-sensitive 6-meter-wide horn antenna kept detecting the same noisy signal at all hours of the day. And originally, after checking the instrument for normal things, they thought that the problem was the fact that two pigeons had created a nest inside of the horn, and they were actually detecting the droppings, the poop. Even after capturing the pigeons and cleaning up all of their poop, this signal persisted, and they were actually detecting the afterglow of the Big Bang, the beginning of the universe.